Hi, hello everyone. So happy to be here. Okay. I just encounter a abrupt situation that these days I am a little bit busy with my work. So maybe I don't know. Maybe my videos will be postponed. So I have to apologize if here are some people care about my videos. I'm so sorry for being late. But I will just supplement as soon as possible. Yesterday is Tuesday. Originally, I will post the financial video. But I have arranged and want to make the Tuesday can put not only the financial videos but also the law and the politics. So the Tuesday will not be defined. Just only can put the financial videos, but also the law and the politics. So this is Tuesday. So other days on a week is just the common days. So the Sunday and the Saturday we will not put any videos. So just like I have told, so I just want to make all the videos can be put it on. These days because I'm just employed by a company, so that is a little bit busy with my new job. So because I have to make the new job first in my old stuff daily life, so I have to sacrifice the recording time for my videos. If you feel very pity, or if you have another very useful suggestion, I'm very welcome for your recommendation. That will be very fantastic if you really have some. Okay, today we have to finish this section. This section is very simple. It is just a talk about the law of conservation of mechanical energy. This section is very simple. We just bring two questions. So, what is the law of conservation of mechanical energy? The law is the basic law concept in the mechanical energy. It is just talked about if any object or system, or just like the Boolean system, if here is no other forces from outside to make it work, and the internal system, here is only the conservative forces to make it work. Thus, the whole system's mechanical energy will conserved. here we call the mechanical energy is included kinetic energy and the potential energy. So that is introduced and represented. The outside forces work is zero. That is indicate here is no other mechanical work from the outside. Only conservative force to make work. And here is only kinetic and potential energy to transform. And here is no other mechanical energy to transform to other energy. To satisfy the two conditions, the law of the conservation of mechanical energy will be established on the every inertial frame of familiarity. Do you know the things I talk? Inertial frame of reference. Inertial frame of reference. So the abbreviation of the law we can call the material point or the particle. When it just exercise on the ground, the kinetic energy and the potential energy all conserved. They are not changed. Or we call the object in the gravitational field. When it just exercise in a gravitational field, the kinetic energy and the potential energy are all not changed. The saying hint we can neglect. The changing of the kinetic energy from the object on the ground. So we don't need to count the changing of the kinetic energy from the object on the ground. So all of these above only established on the reference, just like the spatial inertial frame of reference. Okay, can you understand all of this when we talk about the law of the conservation of mechanical energy? This is all about the law of conservation of mechanical energy approximately. So the formula in the law, we will talk about the E, and the E is equal the potential energy and the kinetic energy combined. So mgh plus 1/2 mv squared. So the formula is very, very easy to remember when we talk about the law of conservation of mechanical energy. Okay, let's bring a question here. And this section is very simple. We just have two questions we just have two questions needed to be solved. Let's see this question. Just like the chart on the right side, the rope crossed a fixed pulley, and the two sides individually tied up, bind up a material big end and the material small end. The big end is bigger than small end. In the original calm ground, the big end is on the ground. When the small end is descending down about the H height, this moment the rope is bind very tight. The rope and the pulley's material and friction can without accounting. So this question just want to ask you. First, when the rope just be tied up so tight, the velocity of the end. Second, the maximum of the height. When we just discussed the big end, how the height, the big end can be ascended up. Okay, so first, we have to know the small end descending down about H height. The incident velocity V will be 2gh root. So when we just talk about the velocity, when the small end bring the big end, the both sides, the velocity is OV, because they just bring together. When we talk about the kinetic energy law, so we know that a small m multiply the root 2gh will equal big M plus small m to multiply V. Thus we can know that the V's formula. Okay. The M descending down H height, the incident velocity is 2gh root. The small m bring big M, the both side velocity ROV. So we can just bring the law of kinetic energy. The small m multiply 2gh root will equal big M plus small m V. Thus V is equal big M plus small m m is divided by big M plus small m multiply 2gh root. So this is the first question's answer. We have to know that because we know the n and the n, the velocity is equal. ORV. So thus, the material. So thus, the small m multiply the 2gh root will equal big M plus small n multiply v. This is from the definition we have taught in the question. So the law pulling the two objects, the accessory A is equal big M plus small m, big M minus small m, and then multiply g. Therefore, thus, it's just quite equal. We code the big M. The big M is thrown up vertical direction. The big M is thrown up the vertical direction, and the velocity is v. The accessory is a. The accessory is the downward direction. So we can know the v squared minus 2ah will equal the v squared. So thus the v squared minus 2ah will equal 0. And we bring the condition into. Thus we can know that the maximum height we will obtain the formula. Okay, the rope. So, when the rope pulling the two objects, the accessory A, we can know is m minus n divided by m plus n multiply g. Therefore, it is quite we talk about big M. The big M on the V, the original velocity when we throw up the material N, the vertical direction, and here is the accessory A. Direction is downward. So we can just gauge. That's the question. We gauge the V. This question we get the A. But we have to solve another formula. The formula is 0 squared is equal V squared minus 2AH. We obtain V and A. So we bring the condition in 2. Thus we can just gauge. The maximum of the height is equal m squared h divided by big M squared minus small m squared. Okay. Okay, can you understand in this question what concept you have to gauge? So, it is easy to understand. In this section, we only bring 2 questions, so I hope you can just realize some in the 2 questions. Okay, next section we will talk about the motion of the round circle and the vertical plane. Not only the round circle but also the vertical plane. To discuss the motion. Okay, thank you for your watching. We'll see you next time. Bye bye.